Okay, so welcome, and today we're going to start a topic that is a very important topic, and it's going to be infinite sequences and series. And so we're going to start by taking a look at an example. And so what I've drawn on the board, as far as I can tell, is an equilateral triangle. And so if I take this equilateral triangle and I attach another equilateral triangle in the middle 1/3 of each of the sides. So basically take another equilateral triangle that basically takes 1/3, the middle third of the side. So if I do this, so again, something like that, okay? And then what I'm going to do is I'm going to then take each one of these sides of these smaller triangles. So if you think of like another triangle here, another triangle here, another triangle here. So each side, I'm going to do the same thing. So I'm going to put a smaller triangle here, another equilateral triangle here, 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 and here. Oh, and here, and here. Okay. Now what I'm going to do is I'm going to do it again on all of these sides. Every single one of these sides, I'm going to pop up another equilateral triangle. So I get here, here, yeah, here, here, here. So something like that, okay? And so if I keep going over and over again, you'll see what happens. So this is what we call a fractal. This is a very famous fractal, and this is called the Calc snowflake. And the Calc snowflake was discovered, it was named after the famous mathematician Niels Flavian Hilge von Calc. So this is called the Calc snowflake. He was a Swedish mathematician. And so this is what we call a fractal. Fractals are extremely important. They come up all over the place in nature, everywhere, in physics, chemistry, obviously, in the natural world. So again, you look at a tree and you look at the way the branches, those branches are happen with an idea of fractals. Your bloodstream, all the blood vessels, as they branch out into the various parts of your body, happen with a very special, represent a fractal. Leaves, right? So again, if you look at on the leaves, the way the leaves branch out, represent fractals. So rivers, oh, there's another one. Look at a satellite picture of the rivers in a geographic location. The rivers go have a main branch and then branch out into smaller and smaller, you can represent that as fractals. Okay, so fractals is really important. And so why is that important? Why does it, what does it have to do with infinite sequences and series? Well, you can represent things like this as an infinite sequence or series. Okay, and so infinite sequence and series are extremely important, and they come up all the time. You can use them to represent infinite polynomials, what we call infinite polynomials. You can use them to solve complicated functions. You can, for example, the Schrodinger equation can be represented as an infinite series. What else? In integral calculus, obviously you're going to see that it's used in integral calculus. You can use it also in differential equations. Also, it's used in business, right? So we're going to talk about the Taylor series. Frederick Taylor was a mathematician who came up with the Taylor series, and actually the Frederick Taylor series has been used in time studies. For example, in manufacturing, you can use it to make something more efficiently, like a process, right? So as far as like an assembly line, so you could use it in that regard. So many different applications come up with infinite sequences and series. Okay, so what we're going to do is we're going to study this, and then we're going to start applying it. Hey, how does this work with something like this? Okay, so in the next video, I'm going to start talking about basically the definitions, vocabulary of a sequence. So we're going to start with sequences, and then once we have an idea of sequences, then we'll take the next step to a series. Okay, and we'll figure out, definitions and so forth. Okay, so until then, see you next time, and have a great day.